Well, good morning, everybody, and welcome to the first of three webinars this morning for today from Smart Vision Europe. My name's Jarlath Quinn. I'm an analytics consultant at Smart Vision. I'm joined online today by my colleague Rachel, who just been making sure that everybody's logging in correctly. This is a session that we run on a regular basis. This is called Getting Started with IBM SPSS Statistics, and it's very much an overview of IBM SPSS statistics and just a tour through some of the key functionality, starting with a raw data file, showing you how you set that up, showing you how to manipulate data, and showing you, a few things that you might do to analyze a given data set, really to get people primed so they can, and to inspire them to learn how to use SPSS themselves. If you haven't joined in these sessions before, you should be aware that they are recorded. So you'll be able to listen to them again, they end up on YouTube. And there's some slideware here, not a great deal. Most of it's a demonstration, but we will email out to you a link so you can download a copy of the slides that I'm showing today. If you think it's particularly useful for colleagues who are unable to attend, it may be possible for us to rerun it on a private basis if you get enough of them together. And the best thing to do is just ask us to send us an email, and we'll see if that's possible. And with regard to asking questions, all the lines are muted. So we ask you to use the chat panel. If we run out of time, we'll follow up with you offline, which is what we do on a fairly regular basis. You can also, of course, just send us an email afterwards if once you've had a chance to digest what we're talking about and showing today. We're used to getting emails on a regular basis from people who've attended webinars and people who've just got general queries about SPSS and about its functionality. If you don't know who we are a gold accredited partner to IBM, um, and we specialize very much in the SPSS product line for IBM, but also the other analytics product lines, including the Watson X platform, Watson X AI, Watson X Data, etc. So their cloud platform. But we also a partner to Predictive Solutions and Data Robot. And as I say, our background is very much in statistics, machine learning, data science, advanced analytics, big data, all that type of stuff. We do, of course, work with open source technologies as well, including things like R and Python and Spark. And we're a relatively small organization. We're made up of experts in analytics who have about 15 to 30 years of experience working in the advanced and predictive analytics industry. The common denominator is that we've pretty much all worked for SPSS Incorporated at some point in the past. I think most of us met in the early 1990s, so some time ago. I've worked for SPSS for a long time and then for IBM and also for SAS, the SAS Institute, as a analytics consultant and statistician. So that means that basically we've got a lot of experience of applying this type of technology across lots of different sectors and lots of different applications, whether it be healthcare or central government, local government, retail organizations, oil and gas, water, utilities, telecommunications, manufacturing, etc., media, and digital technology. So, we've got a lot of war stories and a lot of projects that we worked on and applications that we've developed using SPSS, but also other tools as well. And some of them have just been insight-based applications where we're analyzing data to try and cover insight, and others have been more operational applications where we've been trying to predict outcomes and make recommendation engines or forecasting systems or do generative AI and apply that to open-ended text, etc. Point is, if you're interested in talking about these things to us, you should reach out and we'll see if we can address it. To begin with, what we're going to talk about is SPSS statistics today. We're going to be talking about SPSS statistics and just giving you a bit of context, background to it. And then we're going to get into a demonstration and we're going to start out really starting with the real basics of, how do you get data into the platform, how SPSS likes its data formatted. This is very important. Most people who are new to SPSS, who kind of start off working with it, if they don't take a little bit of time to try to educate themselves, they often run into problems because they don't know how the system wants the data to be formatted. So that's quite important. And then we're going to talk about, how we can manipulate the data, how we can filter data, how we can create grouped or banded fields, the different types of analytics we can do, bivariate, univariate analytics, crosstabs, chi-square tests, that type of stuff, charting. We're going to look at using the SPSS custom tables functionality to create some tabulation. We're also going to look at some statistical significance testing, which we're going to look at in much more detail later on when we run a webinar on significance testing specifically. So it's something to bear in mind. You should also bear in mind that the next webinar we're running today is about data cleaning. So we look at all the issues that people have to address when dealing with messy data and how we deal with that within SPSS and all the different techniques. So if that's of interest to you and you haven't signed up for those webinars, please do so. So let's start off talking about IBM SPSS statistics first of all. So it's a pretty old platform. It's been around for a long, long time. It's since 1968 one of the world's most popular data analysis and statistical interrogation platforms. Very difficult to talk about a typical user of SPSS these days. And once upon a time, it may have been psychologists and social scientists who used it maybe back in the 60s and early 70s and so forth. But it quickly started to get adopted by other sectors. So it's now used in healthcare research, epidemiology studies, business reporting, a lot of business applications where people are analyzing their databases, stuff like direct marketing and credit risk, even things like manufacturing process modeling and asset management in telecommunications, etc. And the sorts of things that you would get in a basic installation of SPSS, given that it's a modular system, things that you'd expect to see would be things like crosstabs, frequencies, descriptive statistics, lots of statistical tests, things like t-tests and correlations and ANOVAs, if you've heard of that, or prediction for numerical outcomes, linear regression, that would be all in the basic stuff, identifying relationships in groups, such as factor analysis, cluster analysis, as well as a host of data manipulation methods, the ability to integrate with third-party routines that you can call from R or Python, and the ability to do a lot of charting and to export your results in different formats to different third-party platforms. So quite a lot in the base itself, but you should be aware that it is a modular system. These days, IBM tends to bundle stuff together. So you talk about the premium bundle and the professional bundle. And it really just reflects the fact that people have different needs. People working in marketing and so forth might use direct marketing, might use conjoint. People who are interested in retail might have forecasting, or if they want to do forecasting or time series analysis. People working in healthcare tend to have advanced statistics, which is much more complex statistical routines like survival analysis or generalized linear modeling, that type of stuff. But certainly, as I say, the base itself will cover quite a lot. I would say a typical installation would be something like base, tables, regression. And I would say something like decision trees is definitely well worth looking at. I think a lot of people don't know about decision trees. I think it's really powerful and it has multiple uses across lots of different applications. So if you've never heard of that or looked at that before, maybe you should check that out. We'll have recordings of that on our website as well as many other recordings of other applications we've looked at. An example module, such as the decision trees module, would simply appear as another item in a menu. So you would see that under the Analyze menu, you'd simply see in the classification submenu, you'd see decision trees, and decision trees would seamlessly appear. It would be unlocked with a license code in SPSS. And decision trees, for the record, are used to build predictive models, very much modeling without tears, if you like. They're very visual in nature, very useful for creating profiles of customers or employees or clients or finding key behavioral segments. And they're popular, as I say, because they represent models in a fairly easy to understand way, because they're very visual in nature. So you get these sort of, looks like a family tree. Here it's showing survival on the Titanic, for example, and it shows what factors drive survival on Titanic, splitting the data from the 2,201 passengers, where 32% survived into the lowest survival group here were their second class male adult passengers where the survival was only 8.3%. So as I say, we have recordings that look at decision trees. I use it a lot in survey research and business reporting. And I think it's if you haven't used it before or you're not familiar with it, you should check it out. Suffice to say that we have little video guides, really short, like less than 3 minute video guides, overviews to all of the different modules. So if you're interested in, what exact test is or what's in the neural networks module or the regression module, you can simply click on that and it'll give you a really quick overview of where it's used and how it's used and what you get for that. Okay, so we're finally getting to the point whereby we're going to do a little demonstration here. And the thing to bear in mind is that, if you're working with SPSS or SAS or R, or Python, if you're working with Python for an analytical capacity, or if you're working with Stata or Statistica or Minitab or any of these tools, there are generally three things that you have to be able to do in order to make good use of them. The first thing you have to be able to do is you have to be able to get data into the system. So often the data hasn't been collected with analysis in mind. It's been collected with something else in mind, like marketing or, management of stock or something like that, or it's a HR database, something like that. So you need to be able to get that data into SPSS. You need to be able to format it. Second thing you need to be able to do is you need to be able to transform and manipulate the data. So you might want to filter out people who aren't relevant or cases which aren't relevant. You might want to compute a field or something like that. You might want to collapse categories together. You might want to create banded versions of them. You might want to aggregate the data. So all of this is stuff that you do to transform and manipulate data. And the third thing you want people to do is, you want people to analyze it. So you're going to have some chops, some experience with regard to what's an appropriate analytical technique to run and how you get the results of that technique perhaps into a report or to send the results of an analysis that you've done maybe in the data form, the data that you're creating out into another platform like a spreadsheet or a database. And then in a introduction to SPSS course, you would expect to cover all three of these things. You'd try to hit each of these three waypoints so that everybody comes away knowing the basics of how to get from A to B or how to get from A to Z, and indeed with regard to working with raw data, manipulating the data, cleaning it, getting it into shape, analyzing it, and sending the results somewhere where others can consume it. So the first thing we'll do is we're going to take a quick look at SPSS, and we're going to start on this first point of reading and formatting data. So if I just Alt tab out here to SPSS, this is SPSS version 30. I wouldn't worry too much if you've got a version of SPSS and it's not this version. Really, don't worry about it too much because the differences between the versions of SPSS, particularly in the last 10 years, there are very, very subtle differences between version 29, version 30, version 28, version 29, so forth. There's always a few extra bits that have been added each time, but generally speaking, they're very, very similar, and you wouldn't necessarily know to look at them which version you're talking about. So the first thing I want to do is I want to read a data set. I want to get a data set into SPSS, and it turns out this data set's not an SPSS file. SPSS files are called SAV files. If I go to File, Open here, just as you would, this is a Windows application, File, Open Data. You can see it's looking for these files called SAV. These are SPSS native files, SAV files. And the file that I've got, as I've been here in all files, you can see there's lots of other files here, including PowerPoint files and stuff. And I'm going to try to read in this workbook, this XLSX workbook called Employee. I'm actually going to take a slightly different route to do that. There's more than one way to do that, but I'm going to formally click on Import Data, File Import Data, and then click on Excel. And then if I click on Excel workbook.xlsx and click Open at that point, what it does is it starts a little wizard. Or it starts a little, in this case, not so much a wizard, but a little dialog box opens up, which shows me a preview of the data and gives me a few controls for what I can do to the data. So I can see what the data looks like, and it's correct. It says, look, It's guessed that the data starts in row A1 and it ends in J476, which is true. So it kind of makes a guess where the data is. It says I'm assuming that the variable names, the field names, they're called variables in SPSS, are in the first row of the data. They are. If they're not, you can actually alter this range and tell it where the field names are. It says I'm going to guess what type of field it is. So if 95% of the field is numbers, then I'm going to say that that's a numeric field. If 5% of the field contained letter characters like A, B, or C or something like that, it would, because it's only 5%, it would say, well, I'm going to assume that as the remaining 95% are numbers, I'm going to call that a number field. You can switch that off and say, no, no, I want you to look at all of the values in the field to determine what type of field it should be. I'm going to ignore hidden rows and columns. And something which you might want to bear in mind is that sometimes you see here you've got a field like gender here, which just says M and F. It is possible, as you'll find a lot when you're dealing with data cleaning issues. It is possible you'll get something like F space or space F or something like that. So there's a hidden character. SPSS will interpret that as a separate character from just an F on its own. So you can ask it to trim off if it says if there's any leading spaces or trailing spaces, just trim them out. So if you've got things like postcodes and stuff like that, you might want to click these options here. If I click OK at that point, it just reads in the data and it comes in completely raw. It's just it looks very like the data as it would appear in Excel. You can see the field here, gender here is very squished. That's because it just makes the column as wide as the number of characters in it. So I can make it a little bit wider by stretching it. And we can see a field here like job cat. It's a numeric field. It's got these little symbols across the top of it. We'll talk about that in more detail, but we don't know what these numbers mean. 1, 2, 3, that type of stuff. We don't know what they refer to. We can guess what numbers like salary and sal begin means, beginning salary and current salary. Minority, we don't know what the 1 means. We don't know what the 0 means. Job time, there's a lot of 98s here, 93s here. It might be sorted in that order. Maybe it's sorted in that order. But
Jarlo,
yes.
I'm sorry to interrupt. I think you might still be sharing slides.
Oh, I'm terribly sorry. That does happen sometimes when we're working with Zoom.
I think it went up and then might have gone down again.
All right. Okay, let me try and reshare. Share screen. Okay.
Yeah, we're in.
Okay. In that
I'm so
case,
sorry.
that's all right.
I
In that
saw it
case,
and then okay.
let me start again then. We'll go back to file new. It just happens with Zoom. Sometimes it loses the share.
Yeah, yeah.
Okay. Okay. So this is what SPSS looks like. It's a sort of spreadsheet-like format. If I want to import the data, I think the first thing I did was I went to File, Import Data here, and I went to Excel, and I called up this Excel workbook here. So it's just like I'm opening a document. SPSS would normally read what it calls SAV files. These are SPSS data files. Um, and if I click Open at that point, it starts this little dialog box for me where it's showing me a preview of the file, showing me a preview of the data file. And you can see it says read variable names from the first row of data. Well, it turns out that the variable names are in the first row of the data. So it's going to read that correctly. And the next little checkbox here is it says percentage of values that determine data type is 95. That just means that 95% of the values in a column it will use 95% of the values in a column to determine what type of column that is, what type of field that is. So if you have a data set, as I say, if you have a field where 95% of the values in the column are numbers, it will assume it's a number field and it will format as number. Whereas if I switch that off and say this field here had the values A and B in it, and it only occurred twice, maybe less than 1% at the time, it would say, nope, I'm going to determine this field here to be a string field because I want to keep the A and the B. So basically, switching that on, not default, is switched on. It says, look, I'll just base the type of field it is on 95% of the data. You could change this, of course, to 99% if you wanted to. And you can see here it also says remove leading spaces from string values or remove trailing spaces from string values. Um, with the what all that means is that when you have a character string column, you might have something like postcode, you might have something like I don't know, let's say something like test grade, like A, B, C, D for people's students' tests. It is possible that when people are inputting that data, particularly if they're inputting into a spreadsheet, that they just accidentally put in a space or something like that, some hidden character. And it looks like it's a normal, a perfectly normal and legitimate character, but in fact, uh, SPSS will see that as a separate value from a character that doesn't contain a space. So checking these boxes here just says to it, look, if there's any leading or trailing spaces in there, just trim them out, just get rid of them. And it's something to bear in mind. It's quite a useful way to deal with those types of issues, if you like. You can see here it says the final data type is based on all the data and can be different from the preview, which is based on the first 200 rows of data. So the preview here, little preview here, is just to give us an idea of what the data looks like, and it just shows us the first 200 rows of the data. So that's really useful because, we get a little preview of the workbook that we're trying to read here. If the workbook, for example, had more than one sheet in it, we could point it to other worksheets and it could read those in separately. Or if the data started in a different location, here the data starts in cell A1, right up in the corner. Let's say the workbook had a title or something like that in it. You might, the data might actually start down in cell A4 or something like that. So you could put in a range at that point, and it would put you could read it. You could read a separate range. But if I click OK at that point, it's just going to read the raw data in. So it just reads the raw data in. You can see you've got these different values in here. You can see that gender is a bit squished, as I say. So if I stretch it out, I've got M and F here for character, obviously male and female. Here, this is obviously a string field here because it's not using numbers. The number fields are displaying numbers sometimes with a decimal place, even though it doesn't need a decimal place. But you can see fields here like job cap. We don't know what these numbers refer to. We can see a field here like minority where we got a 1 and a 0. We don't know what those numbers refer to. But that's how we would begin the process. Having got the raw data in, we would now format the data. So that's one example. I'm going to show you another example of another data set. That's an Excel workbook. What if the data set is a database? If I wanted to read in data from a database, well, then I'd go to File, Import Data, Database. And in this case, I happen to just have I've got more than one database here. Actually, I've got one which is a SQL Server database. It's got tons of different databases in it. It's got loads. You can see there's all different. You can see I could drag these across. Or alternatively, I go back one down a wizard here and I'll say, okay, actually got a little access database I'm going to connect to. And I can go and browse for that. How does it know where to look for them? Well, these connections are set up using what's called an ODBC connector. That is Windows. This is Windows. This is just calling up a Windows application. You could literally go into Windows search and just search for ODBC. And you define a connection here so that anybody using your copy of SPSS or using your copy of SPSS on your machine can access that database. Sometimes you might need, if the database is sitting somewhere else in the organization, you might need access to it. You might need a password to get into it, in which case you need to talk to your IT people. But suffice to say, you can't do that. You can connect to a database pretty straightforward. So if I click on an MS Access database here, hit next, I'll search for it. Weirdly, this is a bit of a gotcha. I don't know why, but you can actually read an Excel file through here, and although it's an MS Access database I'm looking for, it defaults to an Excel file type. I don't know why, but if I change that to Access, you can see there's employee data.mdb. That's an Access database. I click OK at that point. It's just got one table in it. You might have multiple tables. You might have a table for, salary details. You might have a table for address details, a table for, service history or something like that. We just got one table here. And if I drag that across, you can see it shows me all of the fields in it. And I'm going down through this wizard. I can tell it not to read all of the data. So this is what this limit retrieve cases step is if I want to create an expression here, maybe a SQL expression to say, no, only select people who've joined the company, I don't know, in the last 4 years and exclude people who've since resigned or something like that. If I go down to the next bit, it says, okay, this is what the field names are going to be called, and the variables as SPSS calls them. Hit again to this point. It shows me the SQL that it's going to generate for that, or I can paste it as SPSS syntax. SPSS syntax is the language that SPSS uses to run itself. If I click finish at that point, it says, okay, do you want me to save the changes to the current data set you got open? I say, no, don't worry about it. Just overwrite it. And it just overwrites it. And it's the same data set as before, except we've got one additional field here. We've got a field called age, which we didn't have before. Okay. And you can see the field here, birth date, has been shown. This is an actual date field showing their date of birth. What can we do here? Well, we can format this. We can start the process of formatting this. I'm just going to show you very briefly how to do that. So if I click on gender here, I can go to this tab here called variable view, and I can see all the different fields. Here's gender, and I could say this should have the label, employee gender or something like that, or sex of employee. This data is from the 1980s. It was actually quite a famous data set. Um, it was quite a famous data set that was used in a court case for a bank in Chicago. And the court case was where some of the people, I think the clerical workers, had brought a case against the bank for unfair pay practice. So it was basically an equal opportunities court case database. And as a result of that, it's got a lot of data that refers to their job category, their beginning salary, their starting salary, their education, how much time they've spent in the job, their previous experience, and whether or not they're an ethnic minority. So you can see here, here's gender being set up, and I'm going to attach some labels to this. I could say, okay, I've got F for the label female and M for the label male. Click OK at that point. If I come back to it, you can see now I've got these labels appearing on top of that. So these labels have appeared. So that's interesting because what happens is if I right click on that and I ask for descriptive statistics, it immediately just does some basic analysis for me and squirts the result of that analysis out onto an output viewer window for me. And here we can see 45% of the data is female and 54% male at that point. Okay. And then we could do the same thing here for this variable job cat, but the problem here is I haven't formatted job cat, so it just appears as 1, 2, and 3. So I'd have to go through the process of telling it what the values 1, 2, and 3 meant in job cat. Here, birth date's showing a time on it. I might go to the date formatting here and say, look, I don't need the time shown on that. I just need the date because I don't have the time. So that reformat. This is the business of formatting the data. You can see that we have lots of different things we can set up here. Set up the width, the number of decimal places, each label for the fields. So this is the label is what's going to appear above a chart or a piece of a bit of output rather than the word educ. The label, years of education would appear much neater in that way. I'm kind of front loading my efforts. I might also set up a missing value. So I might tell it that, for example, if you see a value like X in the gender column, that means the data is missing. If you see a value like, I don't know, a value like minus 99 in the salary column, that means that we don't have the salary. It means it's missing. And we can tell it what type field it is, whether it's a category field or a number field, and so forth and so forth. Well, I haven't got time here to set all of this data set up here in front of you. But it turns out if you've already done this once in the past, you can actually do it again very quickly just by using the previous file as a sort of template. And to use the previous file as a template, I simply go to Data, and I go to Copy Data Properties, and I search for the previous file, and I've got a file here called Employee Just the Variables. Click open that point, hit Next, and Finish. And immediately, as you can see, it immediately just formats the entire data set here. So now we can see that job cat is actually these codes refer to whether or not they're a manager or a clerical worker or a custodial worker. If I right click on it and ask for descriptive statistics, we can see that now that it's been from job cat, this was the previous table. Now it says employment category, clerical, custodial manager. And if I go to variable view here, we can see that pretty much all of the fields have been correctly formatted, apart from age, because age didn't occur in the previous data set, so it didn't have any properties to copy across for that. So I could just put in age of employee here. The other thing that's really useful is it does pay attention to the type of field it is. So if I ask for descriptive statistics on age, it doesn't give me percentages and a frequency table because it knows it's a number field. It just gives me the summary stats. So it says the mean age is 37, the youngest person was 23, the oldest person was 65 in this bank. And there are 5 values where it's missing. And in this case, missing data appears as a null, if you like, is just a full stop. That's a period symbol. That's called the system missing value. So sometimes you can have a special value like minus 99 or 0 or X or something like that for a string field to indicate the values are missing. But if the cell's just blank, then it just puts in a full stop or a period symbol to indicate it's missing. So all of this is about how we format the data and how we get it in shape for us to analyze the data. What about actually doing some analysis of this data set? Well, you saw how I was right clicking here. There's this really useful little procedure here where I can just right click and say, just give me some descriptive statistics. That's a kind of a quick and dirty way to get some analytical output. It's just saying summarize that column for me. What it's really doing is it's going to the analyze menu here and it's running a procedure called frequencies. And if I go to frequencies here and pick up, say, minority classification, it's going to produce exactly the same output we saw earlier, but I can also ask for some charts. I can ask for like a pie chart here. And I could ask for some statistics if I wanted as well, but it doesn't really make any sense in this case to ask for, average minority classification because there's only 2 groups here. One is yes, no. You can see there's a special category here, 9, which is a missing category. And there's 3 occurrences of that. And that's why we have 2% columns. We have a percent and a valid percent column in the frequency table here. So it's just showing us that, when we look at all of the data, all 474 cases, 0.6% was missing. But if we just look at the legitimate values, then we take those out and you can see there's a slight difference in the percentage of people who were in the ethnic minority group and those who weren't. So it goes from 21.9% of all the data to 22.1% of those values where the outcome is known, which is the valid percent. If we wanted to give this a nicer label rather than just missing and maybe put unknown, it's very simple to do that. You would just basically double click on that and you'd go into the label here and you'd say, okay, I'm going to add a little label here and say, look, when you see a missing value here, which is 9, you can see the missing value is coded as 9. Just call that unknown because it might be that it's not just missing. It might be that it's something like not applicable. Like how many years have you worked in management or something like that? It might be not applicable. If I click on unknown, change to unknown, it just makes a slight cosmetic difference. Now it says unknown rather than just missing, rather than just blank next to the missing group here. So we can label up the values here. That's the point. So what would happen if I tried to do the same thing if I went to analyze and went to descriptive statistics and frequencies again, but this time I did it with age of employee? Well, it probably wouldn't make a lot of sense if I did that, especially if I asked for, as you'll see, a pie chart here, because age of employee is a different type of field. It's a numeric, it's called a scale field. And, as you can see, what it's trying to do is it's treating every age as if it was a separate category. And when we get down to the pie chart, well, it looks crazy. Okay. So what's appropriate here? You can see here that rather than me going back to analyze descriptive statistic frequencies, I'm using a dialog recall box button. This is really useful because the process of analyzing your data is iterative in nature. So you tend to do the same thing over and over again. If I just call up frequencies again, you can see It still keeps the settings from last time. Like I say, no, don't display the frequency tables. I don't need those. And don't show me a pie chart. Show me a histogram because that's appropriate for that type of chart. And then statistics here. Show me the mean, the median, the standard deviation, the minimum, maximum. Click continue and OK. And then it reruns that procedure. And now we can see the age distribution with the mean, the median, the minimum, maximum, the standard deviation, and the number of missing values are. There's actually 5 cases where we don't know what their age was. So it's about the point here is that we choose the right settings for the right type of field, and the type of field it is does make a difference. The type of outcome, the type of analysis that you do. Is there a way in which I could do a frequency table of the variable age? Well, yes, there is. One of the things I could do is I could go to transform here and I could click on visual binning. If I click on visual binning, I can pick up a numeric field like age here and click continue. And what it does is it creates a histogram of that, and I can say I want to create what's called a binned version of this, which means a grouped version of this called age group. And it's going to give it the label age of employee binned. I'm going to just call it banded. Let's say banded. That's better. And then I can tell it, rather like slicing a cake, I can tell it where to slice it. I can tell it where the cut points are. And I can go here and I can say, I want you to put 3 cut points in there so that the cake is sliced into quarters. So the width is 25% each time. And if I can hit apply at that point, it actually puts them in for me, puts these cut points in. And you can see that the second cut point, it goes from 29 to 32 here. So the second point, this group here, there's actually 25% of the data is just in that group there. I might want to move these around. So I might say, okay, look, I'm just going to move that a little bit. And you can see that when I move this interactively, it pays attention to where it's going. So it actually updates it. So these are interactively linked. So I could say that, look, I'm going to change this to make it neither. So it goes to 45. I'm going to change that. I'm going to take that down to, 28 or something like that. I'm going to make these guys here 33 just to make it more natural. And I'm going to say make labels for me, make value labels for me. And it shows me the value label it's going to make. So I'm going to change that one there to over 45. I'm going to change that to under 29. So I can edit these. And when I do that and click OK at that point, it says I'm going to create a field for you called a new field. And that new field is created there. It is age group. If I right click on that and hit descriptive statistics, now it's giving me percentages because it knows it's a grouped variable, a banded variable. And okay, it's not cut perfectly into quarters anymore because I've changed the values around. But you get the idea that I've created these groups for me to work with. Now, what happens if I wanted to look at the relationship between these fields? If I want to look at the relationship between these category fields, one of the things I might do is I might say, okay, I want to do a crosstab. So if I did that, I'd go to descriptive statistics and go down to crosstabs here. And I would it says target list here. It should say rows. They just haven't changed this yet in version 30 yet. It should change it. But it basically means rows and columns. If I'm going to put age into the rows, I'm going to put minority classification into the columns. If I click OK at that point, that's fine, but it's just giving me the count. It's not, it's not great. If I call it up again and say I'll just add some extra values to that, I'm going to add row percentages to it and click OK at that point. You can see now it's saying 87% of those aged under 29 are non-minority, 12% are in the minority group. 35% of those aged 34 to 45 are in the ethnic minority group, and over 45, 29% are in the ethnic minority group. So it does look like the younger people are less likely to be in the ethnic minority group, and the older people are more likely to be in the ethnic minority group. And if we wanted to do a statistical test to see if this was statistically significant in any way, we could do this by clicking on statistics and asking for what's called a chi-square test. We click OK at that point. The chi-square test is showing a value here of less than 0.001. That means the Pearson chi-square. It's a significance value. Generally, values less than 0.05 are regarded as statistically significant. And it basically is showing the probability of getting a result as extreme as the one that we're observing, assuming that there was no relationship between age and minority classification. So we're saying that, look, this is unlikely to just be a chance occurrence. The nice thing is if you actually double click on the output in SPSS and right click it and say, what's this? It'll tell you what that is the significance level based on the asymptotic significance of a test statistics is typically a value of less than 0.05 is considered significant. So it gives you a little clue there. And we could do the same thing. We could look at, say, the relationship between uh, gender. We could do gender here against age of employee. Click OK. Maybe that's a maybe there's a difference there. Look, um, 78% of those aged under 29 are female, whereas 63% of those aged over 45 are female, but only 18% of those aged 34 to 45 are female, and only 24% of those aged 29 to 33 are female. So it looks like we've got this kind of bimodal group here where the females tend to be the youngest and the oldest groups in it, but not the middle aged, not the sort of middle groups. Is that statistically significant? Yes, it is. It's showing it to be that is indeed a statistically significant group. Now, what I can't do with a crosstab is I can't really throw in something like a continuous field. I can't really do current salary against age of employee because current salary has just got loads and loads of categories. It doesn't make any sense. You'd need to have that banded into salary group or salary band using the visual binning that we used earlier on. Or alternatively, I might do a comparison of averages, and I might say, let's look at the means here using compare means and break that down by, say, age group or something like that. Not age group, sorry. Let's do a comparison of current salary broken by age group. Click OK. That'll give me a group of means here. But what I can't do is I can't really mix these together. I can't mix percentages and means together. And I've kind of got quite limited control. I've got some control here over the output. I mean, you can interact with the output. You can say, no, I want to move these columns around and things like that. And if you don't like where they appear, and you can even click on them and say, okay, I want to create a chart from that. You can kind of interact with the output, and you can obviously edit the labels, etc. But you can't do a great deal in the crosstabs box here with regard to formatting. There's a little bit of the formatting, whether or not the order is ascending or descending. I can't really edit the labels once they've been created, etc. So what people have was when they're doing a lot of tabulation, is they tend to use a module like the tables, the custom tables module. And the custom tables module here is designed for us to be able to really create whatever type of tabulation we want. So it really is about customized tables. And what's useful is you can see it gives you a preview of the fields. You can actually see the preview of the values, really useful in there. And you can start to build up a table. So I could say I want to pick up an employment category and slide that across. I want that in the rows. I want to put gender across the top of it. So now it's like a cross tab. I want to put minority classification, maybe as a subgroup within that. So I could put minority classification. I don't want employment category to show as a label, so I'll get rid of that. I might actually not want the count. I might want something else. I might want their ages or their education level in years and put that in there. It shows it as a mean. I don't want the mean. I actually want the median value. That's what they're asking for. They're asking for a table of medians. So I'll say, okay, apply that. So I have a table of medians. They actually want to put a total in here, but they want to put it at the top and call it the base. So I could say, okay, I'll go into categories and totals and say, create a little total, which is kind of overall. We'll call it base here. And we'll apply it at the top and say, apply at the top. And they're not interested in the custodial workers. They just want to look at clerical versus managers. So we'll take those out and hit apply. So you can see you've got a lot of control here. You can click OK at that point. It's producing more output for you. You can then start to build that table up. You can go back to it and say, actually, I want more in here. I want to put in, age category across the side here. So I want to put age category in here, and I want counts, but I actually want the values here, the summary statistics, to be not the count, but the row percent. So now I'm mixing means and medians and things like that, and I'll have the label just as row percent. So it really is giving me a lot of control here. Apply selection, click OK. It's producing a bigger table each time. And, all of the tables have table looks attached to them. So you can format the tables and say, okay, I'll have a different table look and create your own custom table look. You can say, actually, I'll have a different one or a different shade. So web report blue is, I think, my default one. Got this one here called analytical platform, high contrast tables, academic, etc. Simple. Click OK. Produces different tables. So you can create your own table looks, etc. from that. And you can have, as I say, you can create charts from those tables. What if I wanted to filter the data? What if I said, look, I'm not, you saw me taking out the custodial workers there. If I just wanted to look at managers versus clerical workers, the court case was really focusing on clerical workers. If I want to filter them out, the way in which I might do that is go to data and go to select cases. So now we're kind of jumping back and forth between the analysis of the data and manipulating the data. And I might say, look, if condition is satisfied, and I can say, if they are not minority workers, that's what I'm going to say. If they're, sorry, not if they are not clerical workers. Okay, so how do I do that? Well, I'd say if job cut, if the variable job cut, you can see me sending across, is not equal to, if I can't remember what the code is for clerical workers or for custodial workers, I just go up here. I'm going to take out the custodials. I'm going to say if they're not custodial workers, that's code 2, and click continue at that point. Click OK. It turns out that they don't physically disappear from the data set. They're still in there. It's just that what you see is these little strokes appear across the case headers. And you can see that it marks them as not selected. It creates a new field here called the filter field and says not selected. And we know it's worked because if we look at job cut, if I right click on it and do descriptive statistics, they don't appear. The custodial workers don't appear. In fact, I might say until I switch that filter off, they don't appear in any of the analysis. They're basically taken out. Or I could go back to it and say, look, I actually want to create a separate data set and to say, call it no custodials. And then it'll run that. We'll have this separate data set open in the background here called no custodials. And they're just basically, it's a version of the data set we saw earlier on. But the custodial work has been taken out. Or you could delete them if you want to. You're feeling very confident you definitely didn't want them in that session. Just make sure you don't save your data file, of course. If I close that down, I'm going back to the original data set, go back to select cases, select all cases to switch it off, and you can switch it off. Another way to do this is if you wanted to do separate charts. Let's say you want to do separate charts for each of these 3 categories here. Let's say I wanted to do, I don't know, different histograms or something like that. I could go to data and go to split file, and I could say organize output by groups, and I'd split the file up by clerical and custodial and management. I think split file's a poor term to use. It's not really splitting the file, it's splitting the output. Because what happens is if I go to the graphs menu up here and ask it to do like a histogram or something like that of say age of employee, put that in, click OK. It runs that procedure, and you can see instead of just getting one output here, I get one for clerical, one for custodial. There's not very many custodial workers, only 27 in there, and one for managers. And that works until I switch that split file off. Switch it off, I rerun it again, run my chart again, and click OK. And you can see that now we're looking at all the data set again. And while we're on the subject of the chart builder, let's go back to that and just show you a couple of little tricks you can do in here. So if I wanted to represent a crosstab as a chart, normally what I would do is I would do a bar chart, but I'd do a stacked bar chart. So if I did something like employment category across here, and let's look at, say, age of employee. If I put that up there, age of employee, you can see it's creating a banded group here. I could stack this to 100%. You can see that if I run that, it's just going to create this chart. But you can see that there aren't very many custodial workers and manager workers compared to clerical workers. So it's kind of hard to do. I could edit it afterwards. You can see now that stacks it to 100%. It's a bit odd to look at because the colors are kind of just in the order. If I went back to the original one, I could have got around this and done it from scratch and said, look, I want this as a percentage, and I want the parameters to be based on the total over each X category. And I could go to the chart appearance and I could change the colors of the chart here. So I could change them as I'm going along. Or I could go to what's called have a template. If I've got a chart template, and we've created a bunch of chart templates um, in in our on our website that people can download. Let me see if I find some chart looks here. I've got one called Lollipop. I think it's this one, and that is basically that just colors it. If there's an order, an age band has an order because it's the youngest to oldest or something like that. It just colors it in a much more natural way, so we can see where the youngest are, the oldest are. I've also got Lollipop reverse, so that the oldest would be the dark reds versus the greens. But it's just easier to see it, as you can see here. And very important, if you don't like the way it presents the charts, you don't want to be spending time presenting charts, you can copy them as Microsoft Graphics objects out into say something like PowerPoint here. So if I click on PowerPoint, you can see I've got my PowerPoint deck here. I'll just open a blank one. I'll just go, I've got a blank one here. There you go. Oh, that's an older one I did earlier on. And say it. So yeah, if I paste this, you can see it's actually pasting it and it's pasting it not in the same format. It's pasting it as a Microsoft Graphics object. So that means I can go to the chart design and say, look, I don't like it like that. I want it like that. I want to change the colors to this grouping. The layout, I want it to be like that. And I can change the chart type, in fact, so that it is stacked to 100%. Click OK. So you can really play around with it. You can really play around with it and use your own chart templates or your own layouts, etc., rather than just trying to edit the output in SPSS because it'll intelligently understand the output. Okay, we're coming up to the end here. I just need to point out a couple of extra things here, which is that when we're working in SPSS, pretty much anything we do can be recorded in syntax. So we can run stuff in SPSS syntax. That's really important. So for example, if I went back to means here and instead of clicking OK, I hit paste. You can see that it's actually showing me the command that ran. And if I went back to my crosstabs I ran earlier on, I could hit paste on that. And I could do the frequencies earlier on and say, okay, let's do frequencies of minority classification and age of employee, something like that. I could hit paste on that. And you can build up a syntax job and record all of your analysis. In fact, you could do everything from start to finish, from reading the data to formatting the data to applying all of the labels, etc., to producing the output, to even potentially exporting the output. And you can just run it all again automatically. This is really powerful if you're going to be doing analysis on a regular basis. Perhaps you're grabbing data off a database and doing a monthly report, for example. I may even have a syntax job here. That's my data cleaning syntax I'm going to use later on. Let's just see, getting started. I might have one in here. Yeah, sample syntax. There we go. So let's just start from scratch. Go file, new data. That's blank, and let's close down the output. So we're getting no output in the background here. And if I run the syntax, I'll get rid of that old syntax there. So I've now just got two files open. I've got the output and I've got the syntax open. So let's run that. It should, I haven't run it in a long time, but it should just run the whole thing and just grab the data, read it in, and squirt a load of output for me into the output here. Output window, look at this. A whole bunch of charts for me in output, etc. It's formatted the data, it's applied it all to it. So very useful. And you should bear in mind as we're coming up to the end, you can, of course, export this. You can go File, Export, and it'll export it in a range of different formats. PDF. It's a good idea to say export all visible output because there's invisible output here. You can see, for example, for each piece of output, if I click on that, I can see notes about it. There's hidden notes here. It shows me the syntax it ran. It showed me when it ran it, the elapsed processor time, etc. So it keeps a log of everything. And it's very good at logging everything that we're doing. In the background here. Okay, let's just see. How do you filter and delete respondents? Somebody asked this. How do you filter? Well, I did show filtering. So filter, as I say, filtering. If you want to filter them, if you want to delete them, that's select cases. Um, let's see. First of all, go back to select cases. If I said I want to delete everybody that's aged under 30 or something like that, I'd say select greater than equal to, I guess, greater than equal to 30. So everybody under 30. Hit continue. If I say delete unselected cases, that means anybody that isn't in that condition will be deleted from the dataset. You got to be very careful of that, obviously, particularly if you're going to hit save. So you might want to check it first by just using filter out cases, checking it, and just right clicking on the field age, for example, here, and just looking at the minimum maximum. Look, the minimum's 30, the maximum's 65, and say, yeah, that's working. Go back to select cases, then hit delete on select cases. So that's one way in which you could get rid of that, anybody. Um, if you use copy data properties feature and in the file you're using a template, you've reordered the variables and deleted some of the variables. Would that be copied over to have to reorder and delete again? It certainly it only matches by field name. It only matches by field name. So you could see there, for example, in one of the files, I didn't have the same field, didn't have the field age, so it just ignored it. And if I had the field age in the other file and didn't have it in this file, it would ignore it. So it doesn't matter. I don't think field order is recorded in the data properties. I don't think so. I haven't done like you'd have to do an experiment on that and test it. I don't think field order is. But what I would do in that situation, as I have to deal with it on a regular basis, is I would use syntax to reorder the data. And one of the ways in which you can do that, there's different ways in which you can do it. But for example, if I go file, open data here. Let's see, is it open data? Maybe it's file. If I go file, save as. Yeah, if I go file, save as variables here, I can change the order of them in there. So when I save the data file, I can change. So once I've read them in, if I read in my file, applied my template, I can change the order here and tell it what order I want it to save them in. So I could make that as part of the syntax. There's lots of different ways which you can use syntax to move the order of the data around. Okay, returning to SPSS, returning to our slide deck here, having taken a tour through that. Just bear in mind here that in the next section, in the next webinar, we're actually going to be looking at how you clean data in SPSS. We touched a little bit on this, how we format it, etc. We haven't really dealt with problems in the data, of which there can be, myriad problems, a plethora of problems. There's lots of different techniques one could use, including syntax to clean the data. And then in the third webinar today, we're actually going to look at a deeper dive of how you interpret the significance test. We only looked at one significance test, which is the chi-square test. But the way in which we interpret that, where we look at the probability value and make sense of that probability value of whether or not we accept the reject the null hypothesis, is pretty much universal across different techniques. You should be aware that we have a bunch of additional resources. So we've got FAQs, and when you get your PDF of this slides out, you just click on these links, and they'll take you to the video guides, the how-to video guides, mini demos. We've also got Eat Your Greens blog series on statistical testing procedures. Generally speaking, you should be aware that we provide consultancy and help, as well as training and support. We do educational support, whether it be remote or virtual learning or on-site learning, and these could be full day or half day bite-sized courses. And we also help with the recruitment of staff, data science recruitment staff. If you've already got SPSS licenses, we can help you manage those. So you can transfer your licenses to us and make use of some of the benefits of working with a smaller, a more focused expert organization who are experts in SPSS. You can buy your software directly from us. We offer no strings attached technical and business advice relating to all analytical activities to anyone, whether or not they're customers of ours. And we all offer formal technical support services for the IBM SPSS product family to our customers. But we also offer free access to our training catalog to SPSS Smart Vision customers. So that's one of the things you get if you become one of our customers or allow us to look after your licenses for you. So we've got an online training catalog here, which you can either buy or you can make use of within there. I have a large data set in SPSS of missing values, outliers, and inconsistent entries. How can I clean this data set in SPSS? You need to look at the next webinar, Hans, and that's what you need to do because that's exactly what we'll be touching on in the next data set, in the next webinar, how to clean your data. Okay, hopefully you find that useful. We look forward to you logging it again. Bear in mind that there will be a recording of this webinar, and bear in mind, of course, that there are recordings of many, many other webinars and some specialist topics that we've recorded and put on our YouTube channel and on our webpage. In the meantime, thanks for logging in, and we look forward to you logging in again in the future. If you haven't registered for for the next webinar we're going to be doing, I think in an hour's time, then please do so. Feel free to do so. It's free. And the next webinar, we're going to be looking at cleaning data and all of the different problems that people encounter and how they can address those using different techniques in SPSS. Thanks very much.